Okay, let's finish the last section, which is section 11.1b. So let's finish it and then we do the review. Okay, so we say that we're actually looking for the equation of a circle. Whereby we say the circle is, so this is a circle, and then if we have the point here H and K, then this is our R. So any point along the circumference is x y. Any point along the circumference is x y. Now to get a distance from here up to the point x y, then we said what we do is to get the distance r square is the same as x minus h, and then u square plus y minus k, and then u square, y minus k, u square. So to get only r, then our r is the same as the square root of x minus h square plus y minus k, and then u square. So this is the standard form of the equation of the circle. Standard form of the equation of the circle. Now, let's look at an example. We did one example last time. Let's look at another one. Write the standard form of the equation of the circle with radius 3 and our center to be -4 and -10. So let's write this in that. So we know that our HK is the center circle, which is -4 and -10. And the equation of the circle, R square equals x minus h square plus y minus k square, y minus k square. So therefore, we do the substitution here. So we know our R is what? That's 3. So 3 square equals to x minus, our h is -4. Then square plus y minus, our k is -10. Then we square. So this is 9 equals to x plus 4, and then you square plus y plus 10, and then you square. So you can actually expand this, or you just leave it like that. So that is actually the standard form. So that is the standard form. So you can expand it, or you can leave it the way it is. The way it is. Oh, sorry, expand. Now, if we are given the standard form of which has been expanded of the form x square plus 4x plus y square plus 2y minus 11 equals 0. If you are given this one, then you're told to write the circle below or above in standard form. In standard form. So you want to bring this back to r square equals to x minus h square plus y minus k square. How do we write this one in that form? How do we write that? So in this case, what we can do is we can complete the squares in each one of them. So we can complete the squares in each one of them. So we have here our x square plus 4x plus y square plus 2y minus 11 equals 0. So what we need to do first to complete the square is we separate the variables. Putting the variables inside the constant. So here, what you need to do is you now check the constant to that side. So x square plus 4x plus y square plus 2y equals to 11. Now we group them. So we group them according to their like terms here. So we have x square plus 4x plus y square plus 2y equals to 11. Then we do what? We complete the squares in each one. So before you complete the squares, so what you need to do is you need to make the coefficient of x square and y square to be what? All of them to be 1, right? Then you add half the coefficient of x and also half the coefficient of y and square. What you do on one side, you do on the other side. So here, half the coefficient of x is 2. So x squared plus 4x plus 2. And then we do what? We square. Yeah. Plus y squared plus 2y plus half the coefficient of y is 2 is 1. So 1 and then we square equals to 11. What you do this side, you do it in the other side. Plus 2 square plus what? Plus 1 square. Plus 1 square. Then you now simplify. So you now complete the squares here. You also complete the squares here. And then you simplify this. So to complete the squares here, then we take this and that one. So x plus 2, and then you do what? You square, right? And then plus this complete the squares, y plus 1, and then you square equals to 11 plus 4 plus 1, which is equals to 16, which is equals to 16. So therefore it is x plus 2, then you square, plus y plus 1, then you square, equals to what? Equals to 4 square. So our h is equals to what? Our h is equals to what? Our h is equals to what? -2. Our k is equals to what? -1. Our r is equals to what? R is equals to 4. Our center now in this case would be -2 and -1. Then our R is equals to 4. So that is how. Oh. Now, if you're given this now, and then you're told to graph, like graph this, so it is now easy to graph this one. You already have the center, which is -2 and -1. So you just come graph here. So 1, 2, 3, 4, 5. -1, -2, -3, -4, 5, -1, -2, -3, -4, 1, 2, 3, 4. So our center is -2 and -1. So -2 and -1 is, so that is our center. And our radius is 4. Our radius is 4. So we 4. So we have 1, 2, 3, and then 4 up to here. Again, the same distance, 1, 2, 3, 4 up to there. Same distance, 1, 2, 3, 4 up to there. Same distance, 1, 2, 3, 1, 2, 3, 4. So 1, 2, 3, 4 steps. Yeah. So it should be 5 if I'm not wrong. 5 steps. So and then you do what? You circle. Circle. Touch of those points. So that is. Okay, let's do one example. Another example, and then we start our review. Writes the circle below in standard form and graph. It's graph. So we have x squared plus 10x plus y squared minus 10y plus 46 equals to 0. So you use that the variables and the constant. So we have x squared plus 10x plus y squared minus 10y equals to minus 46. Equals to minus 46. Then we now complete the squares. So looking at coefficients of x squared and y squared, they are already 1. So now we take half the coefficient of x, we square, and then we add half the coefficient of y square, and then we add. So we have x squared plus 10x plus half of this, and then we square is 5, and then we square. Then plus y square minus 10y. Half of this is plus minus 5, and then we do what? We square, right? Plus. And then equals what? Minus 46 plus minus 5 square plus minus 5 square. That's 5 square. Then now we complete the squares. Take this and this, you get x plus 5, and then you square, plus this and this is y minus 5, and then you square, equals to minus 46 plus 25 plus 25, which is equals to 4. And this is equals to what? 2 raised to 2. So therefore, our standard form is x plus 5 square, y minus 5 square equals to 2 raised to 2 raised to 2 raised to 2. So therefore, our h is equals to 5, and then our k equals to 5, and then our r equals to 2. So you now come and do what? Load this one. So our center here will be what? -5 and 5. 5 and 5. The -1 -2, -3, -4, -5, -6, -7, 1, 2. So -5 and 5. So -5 and 5 is somewhere there. The radius is what? 2. So the radius is coming up to 3 there. And then you do what? You draw the circle. The radius is the same. So that is how write that. Any question after that? And that is the end of the course. So that is what you were supposed to learn for the whole semester. Was it very hard? It's easy, right? Hey, if you already posted this on your Moodle, so you can still find them. Okay, those who are online, the review is Moodle, so you can still find them in Moodle. Okay, in the next, in the next 30 minutes, let's go through this. Let's go through it. So the exam will be from, what's that?
This one says this is exam 3, but this is.
Yeah, it is not a, no, you're fine. But I'm going to have session 8 and 9. No, we are not. Do you see 8? Do you see 8? So test 3, section 8, chapter 8, 9, and 11. So the other one is just a review. So you can see the review for the exam. But will not be, the exam will not be covering section 7. Just be section 8, 9. So those are just the review, so you can keep them. So right, so our exam. So exam 3 is chapter 8 and chapter 9 and chapter 11. So this is starting from 8.1 up to what? 11.1 up to 11.1. So for for this exactly, which you will be doing, you can just do it over here, and the exam is here. So make sure you don't get sick, okay? So the exam will be here. And the final exam is also here. So also remember the final exam is on Monday 13 from 3 to 5, and it will be here. So for this exam, I will allow you to use your notes. But for the final exam, you will bring one sheet within 2 days. Okay? And it should not be a copy. So it should not be a copy. Like, you don't photocopy someone's. Right? It should be yours. It should be your. So I know some of you have, right? For someone, but it should not be a copy. It should be handwritten. So make sure you write it yourself. Or you can type it. I don't have any issue with that. As long as it's too clear. Okay. There should be one sheet. So for this exam, so I will allow you to use your notes. But if you're okay with it, so you can come with 1 page sheet. Either way, you can come with 1 page or you can come with your notes. But for the finals, you do not bring your notes. So you're also allowed to use your calculator. So you can bring your calculator to class. So you can bring your calculator. So for the final, it will be comprehensive. So I already posted the sample example. So that is the sample of the final. Like that. So the exam will be comprehensive. So it will start from chapter 1, where we started from. I think it was it 2.3? Chapter 2.3, section 2.3. The last. So you could try that sample exam, and then after the exam, I'll give you the solution. After the exam, then you have 2 days to do a review. Wednesday actually, but before your final exam. Okay, so the exam 3 might not be so easy. So please make sure you read. Make sure you read. So it will everything that will be in our exam, we have already done. It will not be outside that is so true. So make sure you read and understand. Do not cram anything. So make sure you read and understand. It might not be easy to some of you, but it can be so easy to anyone else. Okay, now let's look at the review. And let's start from the review of test 3, which is, so it will start from 8.1, chapter 8 and section 8.1. So we did 8.1, we did 8.2, 3, 5, 3, 5, and 4, and 6, up to 8. So if we look at number 1 there, if we look at number 1, if you are given the square root of 72 x squared y raised to 6, and then you're told to simplify that using the assumption that the variables are positive. So how would you So you write that in factors form, which can actually be done one, which can be simplified. So if we have 72 here, then the factors of 72 are what? 2 for 30, 6, 2 for what? 18, we have 2, 4, 9, and then 3 and 1. And 3, right? 3 and 3. So it means we have 2 raised to what? 1, 2, 3, and then multiply by 3 raised to 2, multiply by x squared, multiply by y raised to 6. Y raised to 6. So since this one is the square root, then it means this one is all this is raised to what? 1 over. So therefore, we remember that we can still write this 2 raised to 3 as 2 raised to 2 multiplied by 2 raised to 1 multiplied by 3 raised to 2 multiplied by x squared multiplied by y raised to 1. So if we distribute this power of 1 over 2 in each one of them, then it will be 2 raised to 2 multiplied by 1 over 2 multiplied by 2 raised to 1 multiplied by 1 over 2 multiplied by 3 raised to 2 multiplied by 1 over 2 multiplied by x raised to 2 multiplied by 1 over 2 multiplied by y raised to 6 multiplied by 1 over 2. So when we cancel this and that, you get 2. This will still remain as 2 raised to 1 over 2. This and this will remain 3. This and that will get 6x. That and that will get y raised to 3. Y raised to 3. And then this one will be what? The square root of 2. So finally, what do you get? You get 6x y raised to 3. Absolute value, since that one was what? Even, right? The square root of square root of 2. That is how. So in the exam, simple, actually it's by writing in your song, do it. You don't have to use a lot of space. And not, but if you write something, yeah, then you can write something somewhere. You will be so confused. So you might not get. I will not have that time for it. But if you just put it in a then it's so easy. So easy for you to get the solutions. So that that actually covers so that actually covers even section 8.2 there. So if you look at 8.2 there, that is raised to 3. You do the same thing. So again, if it is raised to 3, you put here what? 1 over 1, 1 over 3, and then you distribute. And then you distribute. Is that okay? Yeah. And then number 8, section 8.3, look at number 6 there. So if you look at number 6, so it is still the same thing. Change this one into equivalent expression in exponential form. So how will you change that one in exponential form? If you are given actually this the cube root of, so this is in radical form. So how will you write this in exponential form? So in exponential form, then this is similar to x y raised to 2 raised to what? 1 over 1 over 8. That one is in exponential form. So the radical form is of this y squared. So this is radical. exponential form is xy squared raised to what? 1 over 3. So this is exponential. Exponential form. So radical exponential. You can be told to write this one in radical form. Then you need to convert this one to this. Are we together? Okay. 8.3 in radical form. You do what? So 2x, and then raised to 2 all over 5. In this one is in exponential form. In radical form, how do you write this? So this is the same as the fifth root of what? 2x, and then you do what? Square. The fifth root of 2x squared. So that is the radical. Any question? Any question? Okay. Section 8.3, those are similar things. 8.3 number 9 there. 8.3 number 9. Simplify 9 over 4 raised to negative 3 over 2. How can we simplify that? So easily. So if the exponent is negative and the value there is a function, what do you switch, right? First of all, you do what? You switch it, right? So in this case, this is similar to 4 over 9 raised to what? 3 over 3 over 2. Now, to simplify this, then this is similar to what? This is similar to 2 raised to 2 multiplied by what? 3 over 2 all over 3 raised to 2 multiplied by 3 over 3 over 2. Right? Right? You distribute each one of them there. So this is basically when you open these brackets, then this would cancel with that. You get 2 raised to 3 all over this would cancel with that. You get 3 raised to 3. And this is equals to 8 over 21, 27. 8 over 27. Is that okay? The next number 10 there, again, you should remember how to distribute the powers there. You distribute the powers in each one of them. Now, number 10. So we have x square y raised to all this raised to 2 over 3, and then all over x raised to minus 1 over 3, then y raised to 4. How can we simplify this? So again, you do it step by step. Open these brackets. Open this bracket. That means you distribute 2 over 3. So this is similar to x. 2 all over 3 multiplied by 2, which is this, y raised to 2 over 3, all over x raised to 1 over 3, which is minus y raised to 1. Y raised to 4. So again, the next step, simplify this. So you get x raised to 4 all over 3, y raised to 2 over 3, all over x raised to minus 1 over 3, y raised to 1, y raised to 4. Now take the values, now collect the like terms. Collect the like terms. So x, this, and this one. So this is equals to x raised to 4 over 3. Take this one up here. It becomes that's 1 over 3. Y raised to 2 over 3. Take this 4 up there. It becomes minus. And finally, this is equals to x raised to This is 5 over what? 5 over 3, and then y raised to. So this is 2 minus 12 is what? Minus 10 over. So finally, since we don't want this one to be negative, right? Then we do what? We bring it down. So x raised to 5 over 3 all over what? Y raised to 10 all over 3. Now, this is in exponent form. So we can still write this as x raised to 5 all over y raised to 10. All this raised to what? 1 over what? Right? Right? 1 over 3. And then this we can write this one in radical form as the cube root of x raised to 5 all over y raised to what? Y raised to 10. So that is E radical. Any question? So if you will be having any question over there, I'll be free. So you can email me anytime before Monday. Okay, so that is covering up to chapter 3. The same thing, 8.3 there. Then if you go to 8.4, which is number 12 there. So we add the like what? The like radicals. So in this case, this is similar to this one, right? So this and this, we add them. So it will be 10 the root of 3 minus 7 the cube root of x, right? So you only add the like radical. Again, I'm sure you review your notes. We have them in your notes. 8.4 there, number 13. Same thing. You need to, so when it is cube, let's say A, and the cube root of B is similar to cube root of the square root of A. If you still remember that. So the square root of A times the square root of B is similar to the square root of A multiplied by B. So the same thing happens here. The square root of 6x cubed y, square root of 3xy is the same as the whole square root of 6 multiplied by 3, which is 18. X raised to 3, y, x, y, like that. So you open that bracket. So this is similar to the square root of 6 multiplied by 3, x cubed, x, y, y, right? And this is equal to 18, x raised to 4, y square, which is equal to 3 x square y. Absolute value. The square root of what? Time is moving so fast. On number 15, you know how to write the conjugate, right? So you multiply by the conjugate. You simplify number 15. What is the conjugate here? The root of 7 plus 2 all over the root of 7 plus what? Multiply by the conjugate. So you multiply by the conjugate there, and then you simplify. Okay, number section 8.5, which is number 3 there. Simplify the square root of 8y all over the square root of 2x. Then this is similar to what? The square root of 8y all over 2x. which is the same as the square root of 4y all over x, which is equals to the absolute value of 2, the square root of y all over what? All over x. Square root of y all over x. That is how. Again, number. This one here. So you do the same thing. So this is 4 multiplied by 2. So it is the same as the absolute value of 2, the square root of 3 all over what? All over x. So it's like that. So we simplify. So we simplify. So you have the solutions at the back, so you can compare with your solutions. You have the solutions there. You can compare with it. Okay. Number 16, I've already told you. So what do you need to do in number 16 here? You need to separate the what? The radicals. Number 16, you separate the radicals here. You take this x to the other side. So it will be the square root of 1 minus 4x equals, when you take this x to the other side, it's 1 minus x. And then to remove this radical here, you do what? You square both sides. So 1 minus 4x equals 1 minus x, and then you square. So you are squaring down 1 minus x. Okay. Number 8.8 is complex root. You know how to do the complex root. So this is similar to the square root of -1, the square root of 98. So the square root of -1 is what? It's 1. Then you simplify the square root. We have cleared, so that's other section you can review for your final exam. Okay, coming back to the next one here, 9, section 9. 9.1. Solve x plus 1 square equals to 25. So how do you solve that? How do you solve that? So to solve that one, then you do what? So x plus 1 square is similar to, so x plus 1 square equals 25 is equals to x plus 1 equals to plus or minus the square root of 25, right? So this is the same as x plus 1 equals to 5, or x plus 1 equals minus 1. So you get the values of, so our x here is 4, or x equals to minus 4, minus 6. So again, 9.2, 9.3, which is number 2 there. So x squared equals 6x minus 1 if the solutions are not, let's say, no solutions. So x squared equals to 6x minus 1. So that is a quadratic equation here. So it is similar to x squared minus 6x plus 1 equals what? Equals to 0. So you can use any method. So in our exam, I'll be a little bit specific. So I can tell you to basic method. So I will be a little bit specific with some of the questions. So number 9.2, you should remember how to use the completing squares. Completing squares. So make sure you remember how to use the completing squares. 9.3, which is number 4, find the discriminant. Remember how to get a discriminant. Discriminant is b squared minus 4ac. You need to remember this. You need to remember that. Number 5, 6, 7, those are the how to solve that. Number 14. If you look at number 14, grab the parabola. Find by first finding all the intercepts, the x-axis, the symmetry, and the patterns. So you need to remember all this. Number 15 is what we did. So one question can be related to numbers 14 and number 15. One question can be related to number 14. Then number 17, 18, and 19, we just did that. So we should. So that is the end of the topic. Today from 12 to 1. And I'm free over the weekend, so you can write an email if you have any questions. Okay, I'll see you on Monday.